Hello everyone, welcome to our pair presentation. It is our ISC 2 activity 2. My presentation topic is electromagnetic thruster and it's presented by Avanti Ray and myself Shankar Farande. Now moving towards the introduction, electromagnetic thruster are a type of electric propulsion that uses both electric and magnetic fields, accelerate, propellant, and they offer several advantages over traditional chemical rockets such as a higher efficiency, lower emission, and the ability to tolerate. In recent years, electromagnetic thrusters have made significant progress and are now being considered for a variety of space missions. Now, we will see the basic principle of electromagnetic thrusters. The basic principle of electromagnetic thrusters are relatively simple. The electric field ionizes the propellant. Typically, a noble gas like a hexagon, the magnetic field then confines the plasma and directs its flow. The interaction between the plasma and the magnetic field produces a force that propels the spacecraft. Electromagnetic thruster can be classified into two main types. First is steady state and another is pulse steady state thrusters. And pulse steady state thruster operate continuously while pulse thrusters operate in short bursts. Types of electromagnetic thruster. There are many different types of electromagnetic thruster, each with its own advantages and disadvantages. Some of the most common types include magnetoplasma dynamic (MPD) thrusters. MPD thrusters use a self-generated magnetic field to confine the plasma. They are relatively simple and efficient, but they can prone to erosion of the electrodes. Hall effect thrusters. Hall effect thrusters are a separate magnetic field to confine the plasma. And they are more efficient than MPD thrusters and are less prone to erosion, but they are also more complex. Plus plasma thruster (PPTS). PPTS operates in short bursts and produce a very high thrust level. They are simple and reliable, but they are not efficient as other types of electromagnetic thrusters. Now, moving towards the recent development in electromagnetic thrusters. Electromagnetic thrusters have made significant progress in recent years. Some of the most recent development includes the development of a high-power Hall effect thrusters. Hall effect thrusters are now being developed with power level up to 100 kilowatt. These thrusters have the potential to revolutionize the space travel. The development of a new material for electrodes and magnets. New materials are being developed that are more resistant to erosion and can operate at higher temperature. This will improve the efficiency and lifetime of electromagnetic thrusters. The development of improved plasma confinement techniques. New techniques are being developed to better confine the plasma in electromagnetic thrusters. This will improve the efficiency and thrust of these engines. Now, the future of electromagnetic thruster. Electromagnetic thruster have the potential to revolutionize the space travel. They are more efficient than chemical rockets and they can be used for a variety of missions, including deep space exploration. Electromagnetic thruster can be used to send aircraft to distant planets and moons. In space transportation, electromagnetic thruster can be used to move spacecraft around in orbit. Satellite propulsion. Electromagnetic thruster can be used to propel satellites. Electromagnetic thrusters are still under the development, but they have the potential to change the way we explore the space. Now, Moving towards the magnetoplasma dynamic thrusters, in shortly MPD thrusters. MPD thrusters are a powerful type of electromagnetic thruster known for their high thrust density and a simple design. They operate by creating an arc discharge between the electrodes which ionize the propellants and generates a self-introduced magnetic field. This magnetic field confines the plasma and directs its flow, ultimately producing a thrust. While MPD thrusters offer advantages like not requiring external magnets, they can suffer for electrodes, erosion, and exhibit complex plasma interactions. And loading to challenges in calling their efficiency at high power levels. Now, moving towards Hall effect thrusters. Hall effect thrusters represent another prominent type of electromagnetic thruster, known for their high efficiency and low electrode erosion. They operate by applying an axial electric field and a radial magnetic field to the plasma. The combination induces a Hall current in plasma perpendicular to both fields, ultimately operating thrust. Compared to MPD thruster, Hall effect thruster offer higher frequency and better throttling capability, but their design is more complex and requires external magnets. Moving towards the pulse plasma thrusters (PPTs). Pulse plasma thruster (PPTs) are different breed of electromagnetic thrusters, and they are characterized by their simplicity and reliability. They operate by creating rapid electrical charges through solid propellant, often telephone, generating a short burst of a plasma that produces a thrust. PPTs excel in application requiring precise control for attitude and orbit maneuverability. However, their lower efficiency, limited total impulse, and need for propellant storage make them less suitable for mission demanding high thrust or extended operation. Now we will see the advanced electromagnetic thruster concepts. The world of electromagnetic thrusters extended beyond the core type discussed earlier. The researchers are actively exploring advanced concepts like pushing the boundaries of space propulsion. Some examples including VASIMR engines. This invites engine combines plasma heating with magnetic confinement and to achieve high efficiency and thrust, making it potential candidate for interpreting travel. Electrothermal thruster. This thruster uses electric heating to accelerate the propellant, often offering a good efficiency for low thrust application like satellite station keeping. Field propellant thruster. It is a very futuristic concept that thruster leverage an electromagnetic field to directly interact with the specific structure, like eliminating the need for a propellant together. And the advanced concept, while still under the development, represent the existing possibility for the future of electromagnetic propulsion and space exploration. Moving towards the role of electromagnetic thruster in future space missions. Like deep space exploration, high efficiency thruster like VCMR will be enable faster and more fuel efficient mission to distant planets and moons. In space transportation, maneuverable PPTs and half-effect thruster will be facilities precise spacecraft positioning and movement in orbit. And satellite propulsion. Efficient and electrothermal thruster can extend the lifespan and the capabilities and satellites, enabling new significant and communication missions. Now, I would like to conclude this session. This final slide serves as a powerful conclusion on our presentation on electromagnetic thruster. It summarizes the key talkway message, and these innovative engines represent a paradigm shift in a space propulsion, opening a door to a new era of exploration. They offer superior efficiency, reduced environmental impact, and generator flexibility compared to traditional chemical rockets, and enabling a mission to precisely cut off reach destinations from venturing into the depth of the solar system of a maneuvering seamlessly in our orbit. Electromagnetic thruster hold the potential to transfer how we travel and impact with the cosmos. As research and development continue, the possibilities for utilizing this engine only expand and painting a bright future of humanities and future advances in space. And that's it all about our presentation. I hope this presentation help you a lot to understand the electromagnetic thrusters. And if any queries, you can contact me. My email address is shankarfarande@gmail.com, and I will conclude my presentation. And thanks for watching. Thank you.